this we have a system of equation 3 by 3. This is something that you should know for final exam. We talked about this briefly in a different session before, but let's just go ahead and solve this. Can somebody tell me what's the first step to solve 3 by 3 system of equation?
You can use the addition method in 2 of the equations to eliminate 1 variable.
Good. So we can use the elimination or addition method to maybe look at the first 2 equations and eliminate 1 variable. Looks like I can eliminate these easily if I multiply either of these 2 rows by -1, right? So let's do that. If I pick the first 2 equations and multiply the first row by -1, then I get -2x, -y, -z is equal to -7. So if I just simply add these 2, I would get let me see, Catherine just ask what about first and third? Yeah, you can pick either of these 3 equations. You need 2 of them to eliminate 1 variable. So you can make a rule of thumb if all the variables are present to pick the first 2 and the last 2. But you have to eliminate the same variable. Okay, so if you pick the first one and the last one, you could, yeah, it just happened that 2 variables would drop automatically. Then you can solve for z. Yeah, this happens, but that's not going to be the case all the time, as you see. So we can make a rule out of it if you like. If all the variables are present, always look for the first 2 and the last 2 and eliminate the same variable. So if I did that in this case, then I would get 3x minus 2x, that give me just x, minus y plus 2y, that give me plus 1y, or just plus y, and z drops to 0, and then that's equal to what, anyone?
2.
Plus 2, yeah. Okay, so we create the equation, 2 equations and 2 unknown. So if I go ahead and do the same thing with the last 2, and this time we definitely have to eliminate the same variable. So it means I have to multiply the second row by what, anyone?
-2.
-2, yeah. If I multiply the second row by -2, I can eliminate the z. Okay, so let me give a minute to everyone to eliminate the z and see what equation do you get. And I'm gonna, while you're doing this, I want to read any other comments that you made here in the chat room. Okay, Catherine, what you made the comments here in the chat room. Go ahead and tell me, what do you mean? I'm not quite get your comments.
Well, I think that there's some problem with kind of reusing one of the equations again, which ends up kind of messing up getting the right answer. So I wanted you to talk about the strategy of that.
Okay. Like I said, if all the variables are present, if we have x, y, z, as you see here, we have x, y, z in each row here, then this method always going to work. If you pick the first 2 equations and last 2 equations and eliminate the same variable, you're always going to get 2 equations and 2 unknown and solve for one of them. So let's finish this one and tell me what did you have in mind. In this case, if I multiply the second row by -2, then I'm gonna, let's copy it down here. I get -6x, -4y, -2z equal to -18. Okay, so if I add the last 2 rows with the new numbers here, as you see, I have -6x plus 2 that give me what? Negative what? 4x.
Negative
right?
4.
And then for y, I would get -3y, right? Everybody? Because we're doing this, adding this to. And 2z minus z would be added to 0. We have 9 minus 18. That would give me equal to -9. There we have it. Now we have 2 equations and 2 unknown where we can solve for x and y. So we have x plus y is equal to 2, minus 4x minus 3y is equal to -9. So let me stop for a moment, make sure we can follow this method again. So if you have 3 equations and 3 unknown, we can always pick the first 2 equations and eliminate 1 variable. We decided to eliminate z here. But if you look at the last 2 equations and eliminate the same variable, then you end up getting 2 equations and 2 unknown, then we can solve for z. So in this case, let's go ahead and solve for it doesn't matter, x or y. If I multiply the top row here by 4, then I would be able to eliminate x. So here give me 4x plus 4y is equal to 8 plus 8. If I add these 2 together, 4x minus 4x adds up to 0. Then here I get 4y minus 3y, give me y. Then y is equal to 8 minus 9, which is equal to -1. And somebody looks like wants to make a comment here. Anyone who raise a hand?
Never mind. Never mind.
Okay, so you're good. So y is equal to -1. So let me go back to. I'm looking at your comments here. Catherine, do you see this works so far?
Yes, but this is a simple one. So, yeah, this one is easy. There's basically the systems of equations on online homework were more difficult.
Okay. What do you mean by difficult is like you have a different coefficients, right? Is that what you mean? Or you mean you saw one that some variables were missing? Is that what you mean?
Well, it was first fractions, and then we were going from there.
Right. So if you see a fraction here, the best method would be to multiply each term by LCD among all those fractions first, and get it into a whole number like that first, and then continue. That's another approach. So in this case, when we find y, we can plug it back into maybe any of these equations and solve for x. So if I substitute -1 here, so I will see x would be equal to 2 plus 1, which is equal to 3. So we find x. Now I can go back and substitute that into maybe a first equation, 2x plus y plus z is equal to 7. If I substitute for each x 3, and for each y -1, I can easily solve for x. So let's see. So you can take it 6 minus 1 plus z is equal to 7. So what is z is equal to, anyone? It would be 5. So z is equal to, did you put 7 over 5? No? Okay. That would be 7 minus 5. Is equal to 2. So there we have it. The solution, we can write it as a number like this. X is equal to 3, comma, y is equal to -1, and z is equal to 2. Again, if you see a fraction here, just multiply each term on each row by a LCD to eliminate the fraction. But for all the test purposes, these are the type of problem you're going to see on the exams and final exam.